Hello and welcome to this video, StorageOS Use Cases, High Availability, MySQL, with myself, James Spurrin, Product Evangelist for StorageOS. This video follows on from the videos Installation and Setup and Storage Classes. We're going to show how StorageOS can be used for high availability storage with MySQL in Kubernetes environments. We start this with a free node Kubernetes cluster with StorageOS installed as per the installation and setup video and the Production StorageClass covered in the Storage Classes video. We're going to deploy a MySQL pod with persistent storage with 2 replicas. When we do this, this could be assigned to any node in the cluster. We're then going to Cordon the running node and what is the primary node for StorageOS data. This will prevent the scheduler assigning to this node again. The pod will then be terminated and recreated, at which point it will be assigned to an uncordoned node and will verify that our data is still available. We're then going to take this a step further. We will access what is the node for the primary source of data, and quite simply, we're going to reboot this whilst it's running. We'll then verify that the data continues to be accessible as desired through the StorageOS cluster. Lastly, we'll check what happens when the rebooted node recovers and rejoins the cluster. All of the resources we've used here are available at the following URL. I very much hope that you try StorageOS, and in the same way I'm showing in this video, you can use these resources yourself on your own Kubernetes or OpenShift cluster. Okay, so we're in the terminal, and if you didn't follow the storage classes video, please run this 00 script to set up the production storage class with 2 replicas. We're then going to create a simple MySQL persistent volume claim and persistent volume using the production storage class. If we check, we can now see that the PV and the PVC are both ready. Next, we create a MySQL pod that uses the persistent volume. For this, we're using the MySQL image with standards that you'd expect for MySQL, and we have the persistent volume claim being used for /var/lib/MySQL, the standard data location used for MySQL. If we take a look at our environment, we can see that all of these are running. We're now going to populate some simple data into MySQL. And at the end there, you can see we've queried that and we can see the output. The StorageOS CLI is a great utility that accompanies StorageOS that we can use to query the status of our StorageOS cluster and volume placement. We're going to run this pod in the background. Now we're going to cordon nodes. We'll be cordoning both the node in which the pod is running and the primary data node. This may vary when you run this. In some instances, it will be the same node, whereas on others, it will be different. Please ensure that you're running in an evaluation or testing cluster that can sustain the cordoning of nodes before proceeding with this next step. Okay, so in my case, the primary location of data is StorageOS K8 free, and the MySQL running pod is running on StorageOS K8 2. And as a result, we've cordoned 2 nodes at the bottom there, StorageOS K8 2 and StorageOS K8 free. Let's now delete the running pod. And now we're going to recreate this exactly the same way as we did before. If we now take a look, we can see that this pod is running on StorageOS K8 1. And if we query our data, we can see that the data is still available as expected. Note, within the actual query there, we have a reset query cache to also ensure that we're actually reading from the disk. Okay, so let's do something more drastic and reboot the primary node which holds the source of data within StorageOS. Again, please take precaution and be careful if you're using the following examples within your environment. We're using the convenient NSEnter to access the Kubernetes node. Alternatively, you can use SSH if you have access. Our primary storage location is on StorageOS K8's free. We've now attached this node and, quite simply, I'm going to reboot, ignoring any errors. If we check our StorageOS nodes using the StorageOS CLI, we can now see that the node is offline. And if we check the StorageOS volume, we have a primary and a single replica. Our data, however, is still accessible as required. At this point, if you take a little break, and what we're just doing is waiting for the rebooted node to recover. And we can see there that the free nodes are now showing as online, and correspondingly, if we check the StorageOS volume, we can see that we have our primary and StorageOS has attached the second replica. So we have replicas on StorageOS K8's2 and StorageOS K8's free. Okay, so that's all. Thanks for your time watching this, and as a next step, please take a look at the rest of our tutorials and use cases. If you're wishing to pursue the use of StorageOS further, you can reach out to myself or our team, and we'll be happy to answer any questions that you have.